Aha.
I am indeed back.
Excellent. We just had a little interlude. We had a little for bash programming just before it cut out by the by this guy.
Ah, wonderful.
I strongly recommend to any viewers to get their hands for it. A bit of a search online, see where you can find it.
Pro bash programming.
Has it? It's got all these. Starts with your first shell script, and then like where to save it, and then looping and branching and command line passing and parameters and shell functions, and on it goes.
Beautiful. I like chapter 10's name.
That's right.
Okay. So I think I'm going to skip that. Hang on. Oh no, I can download it. Okay. So I guess I should share my screen so that something is happening. Let me screen. Download, save file. And then what am I? Yeah, I feel like this, if anyone turns up to these things, because I find just like whatever I'm doing, if it is in some way social, like I immediately just become so much more likely to do it and like better at doing it. So if I can somehow just trick my brain into like, starting as just like the social thing where you're like on Zoom with people or something, then that will probably make me a lot more likely to learn the things. So command line interface, download it, local path of the file. Okay, so SCP is some command to send it to the virtual machine or something, I guess. Let's see what happens. SCP. Oh wait, do I have to be in a local?
So the CP, so it's copy, right? But
okay.
This is the shell copy. So I mean, it's the SSH copy.
Oh, okay, cool. Let me make another.
So it's not copy. It's a whole rewriting of copy that will do it between machines using the encryption and whatever of SSH.
Yeah, right.
So there's a few different SSH commands.
Yeah.
Once you have to have your link up and working, or you have your link up and working.
Yes, but I think I want to be in this directory, right? So hang on. How do I be in my home directory on my local machine? I think this will work because I have the configuration stuff saved in a file. So let's see, SCP. How do you, if you do dash, will that automatically go from the home directory? Like, can I go like, what is that?
Sure, that would be the very home directory.
Oh, where am I? I'm just in C now. Okay. But I want to go from users. Yes, great. And then I want to go SSH copy. And I want to go from /downloads/ what's this file called? cli.tar.gz. And that's going to go to comp, did I call it comp 30,023, which has been set up. Yay! It hopefully worked. Let's see if it really did work. SSH into comp 30,023 and ls. Oh, it's not there. What? Why not?
You're in Jalen, and are you in another? Did you send it to the folder about this one or something?
No, I just sent it to. Well, I sent it to comp 30,023, which in like they have the file, an SSH file, which points that to this,
Mm-hmm.
to this. But
Mm-hmm.
okay, what was the command that I used?
The way it goes.
Let's double check. I used, oh, why is it not there? Why is the command not there? I did SCP, so that's how GZ to comp 30,023. And it said it was copied. So something was copied somewhere. Okay, let's exit this. How do I exit the SSH? How to exit a VM? In Bash. :Q?
I think you need.
No. Type exit. Huh, there you go. Sandy. So why did I do that? Oh yeah, what happens if I just type comp 30,023? No. What's happened? What's happened? Let me just try again. SCP. I believe in going to downloads to be sure. cd/downloads. SCP. What was it? CLI dot.
Can you press that?
Oh yeah, great. There we go. To comp 30,023. Oh, one copied. Now let's try SSHing into there. Oh, what? Oh, I'm in the wrong directory. Let's go back. SSH into comp 30,023. Ah. Oh, maybe it's hidden? Could it be hidden? No. Would it be hidden? No.
What did you copy?
This tar dot, this thing, cli.tar.gz.
So, and you can't go any higher. This is as high as you can go in comp.
Oh, let's find out. Oh, /home. Oh, okay. Maybe I have to go higher. How high can I go? That's as high as I can go.
We'll then do find/name.
Like this?
Oh no, like dash name.
Oh, sorry. Find dash name.
Yeah. And then part of the name of the thing you're looking for.
Permission denied for everything. Cool.
Yeah, it'll look everywhere. Find's a really strong command. Be careful, because it can do actions as well, like deleting things.
Find or can delete things.
Yeah, I mean, not just if you just look for, but like you can give it, you can say
if you give it flags and
each
stuff.
thing you find, delete it.
Right. Oh, is it still searching?
Yeah.
I think it's still executing. Oh, wow. How much am I searching? Am I searching this whole virtual blanket?
Yeah.
All of Unimel's virtual machines.
All right, it should be pretty locked down.
Just thinking of how long the command will be running for.
You can always do Control D or Control C.
Yeah, I never remember what the things. It's like I'm always just press like Control Z, Control X, Control C, like and then one of it works. I don't remember which one it was.
Control alphabet.
Okay. I guess I will have to find that out in the tute. Actually, it's only for this. Anyway, SCP command.
I'm gonna have to go in a bit.
Oh, secure copy. It's for securely copying. Yeah. No worries.
It's SSH copying.
Yeah, okay, that makes sense.
Do you know about man pages?
It tells you about a command. Is that right?
Yeah. So you can do man s. Yeah. So if you do man, see, so it says SCP copies files between hosts on network. It uses SSH for data transfer and uses the same authentication and provides the same security as SSH.
Oh, maybe I need to, or a URL. Interesting. Who knows what happened? Very cool.
So if you look at the very top of this,
sorry.
The man thing,
Yeah.
it's got all those things in brackets. They're all options you can do, but then, and the only things that you have to do are the things that are not in brackets, which is the source and the target. And it doesn't say you have to put anything in other than a source and a target. So I'm guessing what you did was right as far as it goes.
Yeah, weird. There's these exercises here to do with those files, but I don't have those files, so I guess that is not going to work that well. Although I could just do it on my computer. Yeah.
Do you have bash working on your computer?
Yeah, this is git batch, so this will be, yeah. So if I exit, oh, that didn't work. Why didn't that work? Exit. Good. cd downloads. How do I extract? How do I extract this file?
Unzip, maybe.
Yeah, let's see.
Let's see.
So it's tar xf apparently. Let's see. So tar xf CLI tar.gz. ls. Oh, why isn't ls working? Why is ls now not recognized? What did I do to it?
What? You killed ls.
Oh, I mean git command instead of git bash. Okay.
Yes. Oh, looks like you had broken bash for a moment.
Oh, yeah. Bash no longer recognizes any of its commands. I guess I should have moved that to somewhere other than downloads, but oh well, I guess I can do that now.
So what is bash?
Sorry? What was that? What is bash? Hello?
Yes.
I just lost you for a sec. Bash is a command line interface language scripting thing.
Yes, that's probably right. So what I like about it is that, so it started off as a command line a long time ago, like a place where you run programs from. Like that's all you did. Put in the name of a program and ran it. And then all sorts of things got added, and it talks about it a bit in that book that I showed you. And it became made a programming language as well. So you can do for loops in bash and other stuff. But then also, and a great thing about bash is like it really understands like the file structure and whatever, because it's a command line.
Yeah.
Like doing stuff with files and directories is sort of harder in C or other things, because they're not like you can just do that. Find all the files in the folder. Really. But then there's all these little codes that were made in it, all these little bits of code that were written for bash that then do things. Like WC, for instance, is word count. It'll give you the word count of a file. So it's like grown organically and become this weird conglomeration of all those things.
Cool.
So you can so a program in bash is just a text file with bash commands in it, and you just run it from the command line. so you don't compile a bash program.
Oh, wow, cool. Oh, because it's just is running it like if you were typing them in.
Yeah.
Neat.
And as the guy points out in that book, like for him, so then you can do like a lot of real world things because computers are fast now. Lots of things are like just as fast in bash as anywhere else.
Cool.
Like, did a real world getting rid of spam email sort of thing or whatever in bash.
Cool.
I'm in real time. So yes.
There you go. I did not know that history.
Bash does. Yeah. So it's got this really organic kind of history thing. The other amazing thing that bash does is piping.
Yes, that's also in this. I feel like actually as a good segue, we may need to use that to accomplish these exercises.
Oh.
And just obviously let me know when you need to go, no worries. Our first challenge is how many subjects are there in the subjects file? So I've just opened it with cat, but how do we find out how many? Let me try and work out by looking at the commands they've given us here. I'm sure that you already know.
So how do you get that list that you've got there? Where does that list come from?
It's in a file. So I just catted a file.
You're catting a file.
Yeah.
So
hang on, what do we got here? Examining files, head.
Gosh, what do we got?
Rep.
I'm going to need to go in about 10 minutes.
Oh, yeah, I reckon we can definitely command line will be done by then. Oh, wow, I also haven't done Git. Maybe I'll then do a 5-minute Git intro after that. WC, NL to count the number of lines in a file, or WCL. Great. WCL in subjects. 356 subjects. What? How does it know that they're subjects? I guess it just does the file and it's a coincidence. But it sounds like it's saying the number of subjects.
I think, wait.
It must just be the file name, right?
What is that? I mean, what I would normally do is like cat the thing, which is probably not as good really. But anyway, often you've got an output from something and you want to, so if you cat that file and then pipe that through word count.
Like if you do cat subjects.
Yeah.
Like this or sending, you mean that?
No, with it, no piping it.
This?
Yep. You're going to need to put
subjects.
So press the up arrow.
Cool.
Yep.
And I guess that's equivalent to this, right?
So that's telling you how many lines, how many words, and how many characters.
Beautiful.
The lines, you put the -L, /L.
Yeah. Wonderful. There we go. I learned a new thing.
Yes.
What's our next challenge?
Now, the next challenge is how many ones say experimental in the title?
Okay, so we have some actual other challenges. We can also insert an extra one. Experimental. Okay, so there's something here about searching grepping with regular expressions.
Yes.
How do we do this? Grep. Search for and print lines that match patterns. The basic syntax as follows: grep, search pattern, path. Okay, so grep. That's regex. Is it? So we can just do regular. Regex is regular expressions, so you can kind of have patterns to search for. What's the regex for just any character? Is it star? Is it this experimental?
Yeah, but you can just do. But no, you can just do experimental. You don't need the stars there.
Oh, okay. Why are we getting nothing? Do I have to echo it or something?
So that's definitely a file. It's a text file. Subjects is a text file.
Let's find out. Yes.
Yeah, so that should work.
Maybe there's like a...
Try catting it.
Rep, search pattern, path to file.
Yeah.
Why is it not?
Capital E. It's got a capital E.
Where?
All the first all the words start with a capital.
Oh,
You can make grep not worry about it. Yes, there you go. And now suppose you want to count them. How many of them are there?
oh, I'm on it. Don't you worry. I mean, I could count it with my eyes, but that's for losers.
Yeah.
There we go.
Woohoo.
5.
And now suppose you wanted to store that number in a variable.
A variable, not even a
Yeah.
file. What if I want to store it in a?
Oh, files are for losers.
How do I store that in a variable?
All right, so you want an end curve bracket there.
Oh, a bracket. Oh,
An end curve bracket at the end.
what's an end like this?
Open one. Well, yes, but first of all,
Oh, curve bracket.
and get rid of that. Yes. Now go and get rid of the piping thing just before that.
Uh-huh.
Yep. Now go to the beginning of the line. Yes. And now a $sign in front of that curve bracket. Oh, no, a $sign at the beginning. Yep. Yes. And now the name of, stay at the beginning.
Okay.
Everything's at the beginning from now on. Now name of variable and equals.
Yes.
Okay, but what? Sure,
Yes.
equals, but we need that $sign there, and we don't need the $sign at the beginning of the variable. You do need the $sign when you use the variable, but not when you assign it. Great. Woohoo.
Command not found.
No, maybe try putting, maybe get rid of those spaces around the equal. Yeah, there you go. And now if you go echo, yes, but 5's not going to be found. So now echo $sign, and as soon as you press the M, you should be able to press tab and it will just do that all for you. There you go. Woohoo.
There you go. Look at that. Advanced.
So that's
now,
like a lot of what I do when I like it's about as advanced as a lot of my programming gets.
cool.
Do something, make something, and then grep it for the
Put
thing
in
that
a
you
variable.
want. Oh, you know what's really good? What if we want to get, what if we just want to get the names, like the,
Well, it's funny you say that, David, because the next one in the
203.
list of exercises is use the commands, e.g. cut, to extract a list of subject codes.
Yes, another one of my favorite programs.
What does cut do? Cut.
Well, better go man cut.
I don't want to cut any men. Why is man not found? What happened?
What? Man's found. It's not finding cut.
It says man not found, doesn't it? Oh, man. Okay.
Man is telling you.
Yeah.
That cat is not found.
Cut.
Yep.
How do we?
On my computer.
How do I?
Maybe you don't have it. Maybe cut didn't come in your version of Bash.
Extract the subject codes.
You have an inferior one. I'm going to go in a minute. Interesting question. What is cut and grep and WP? Like, what are these things? What are they made out of? What?
I guess they're like programs, right?
Yes. So they're C programs.
Yeah.
That's been written in Bash. And the
Cool.
weird thing is, right, there's like a bit like how like app stores took off at a certain point, right, for phones and whatever. People just started making all these programs, little programs for Bash that do specific things. So there's heaps of them that, like, I don't know, I don't think there's a direct equivalent in C or other things. Like, and you pipe them, you pipe their outputs from one to the other, and it gives a really kind of, I mean, it feels efficient. Anyway, it gives a fast kind of way of cutting up text files and restructuring them and whatever. The most amazing one is AWK. I've never really got my head around it, but I use it sometimes.
AWK?
Yeah, it's AWK. Sed's a good one too. Sed does a lot of finding with expressions, finding and replacing line by line. Yes. Anyway, you don't have it because you have an inferior version of that.
I think I've worked out how to do this.
Okay.
If I have the cut command, cut B 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 subjects. Oh, what just happened?
I
What happened? Does it does cut do output or does
no.
what does it do? Does it just do it to the file? Have I just erased this
It
file?
outputs to the standard output.
Oh, okay, so cut B 10 subjects. Hey, oh no, wait, I cut out the subject codes.
Yes.
Why did that happen?
What I would do is cut.
Oh, I think I've got it. Cut
B, and then D. No, use D.
Way.
Use D. D is ridiculous.
D? Why? What's D?
D is dilemma. So you're saying,
hey, I got it.
Well, you did, but
but not the way you wanted me to.
Ridiculous way to do it. I mean, it's reasonably good.
What's D do?
Another way to do the same thing.
Yeah.
D, you tell it what dilemma you want. So
like one?
So then you do brackets with a space between them. No, not brackets.
Yeah.
Quotes?
Quote.
Yeah, but single quotes. Single quote space, and then another space, and then F. So, wait. And then
flag?
Dash F. So what field do you want? So you want field 1.
What does field 1 mean?
So you're talking about, you're looking
at...
Oh,
you delimit, and then you've got the first
sheet.
thing, the second word, the third word kind of thing.
Yeah.
Okay.
And now you put subjects.
Hey, look at that.
Okay. So now you could do 2, or you could do, so 2 would give you the second column.
Yeah.
Or 1/2 would give you both the first and the second column. Or 1, 3 would give you the first column and the third column.
That's fun. But botany in 2004. Oh, unconscious. I want to do these subjects. Memory, science, global, disease.
Wait.
Ampersand. I want to do this ampersand subject.
What did you search for?
Oh no, I just did the first and the third word. So it's like only using the second.
Oh yeah, so using the second word of each one.
Of each subject.
Yes.
Exactly. Yeah. Investigation. That'd be a fun subject, just in general, investigation.
Okay, now what
criminal investigation. Yeah.
What if we want all of this?
Yeah.
Precisely the output, but we want to delete every S. So pipe it into TR and then /D, -D, and then in quotation, single quotations, put S.
What's TR?
What is it?
It's for deleting stuff.
Yeah, it's mainly for turning. It's either for deleting single characters or for turning single characters into other single characters. So if you don't have the delete.
D's. Psychology.
Yeah, so there you go. So if you, instead of the D, you have just two lists of things in quotation marks, it'll turn things in the first list into things in the second list.
Or we could remove all these redundant zeros that Unimob uses in their subject code. Isn't that so much nicer?
Yeah, perfect. Yeah,
Great.
Using 0 as a placeholder, outrageous.
They're really ambitious about how many subjects they might want to include one day with the old, let's have our subject codes be X'd out, like it's like 30,021 as a subject code. I guess it's good to think ahead.
Yeah. Well,
And also it's within each discipline area, right? Like it's like computer science subject 30,023.
Isn't that what floor it's on or something?
Huh?
Isn't that what floor it's on or something?
What, forward?
What floor it's on?
Oh, well, it's like, you do like 101 or something, but they're like, what if we want to have, I guess you can have up to 10,000 subjects in each year of each. Like if you're like, there could be 10,000 third year computer science subjects. I wish there were that many options.
Imagine how proud you could be if you're doing Zool 30004 and you're like, I'm just doing and. Like, it's so good. Like, nothing ever finishes. We do something and then you just, and, there's an animal. And there's another animal.
It's almost as good as lasers, comma. Very different to just lasers, not to be confused.
Well, what you could do, if you go back to cut, go back to our command there, just get what we had before.
Yeah, I'm going to do it manually so I try and remember.
Fine.
Cut
make the dilemma, make it a comma.
Ooh.
And then choose whichever field you want.
Yeah.
So -F. And the one is.
Oh, yeah.
Thinking about it.
Okay. I didn't put the file in.
Oh, yeah, you need a file. Just right now, it's still listening, so it's still waiting for a file for the first cut.
Hang on. I don't think there were many commas.
Well, no, but obviously there was before mind. So there you go. Or you can use semicolons or colons or whatever can be the delimiter. So it's all about like semi-structured text. Like this is a file and it's got a structure. Not like it's not as structured as a I don't know, like various kind of files of data on the internet or whatever. But it has a structure. Like the first column is something and then there's a space. But then the spaces after that are just within the subject or whatever. It's not a new column. But if you look at that and then you know a bit of Bash, you can cut it up into all sorts of ways you want. You could easily output it into an Excel file if you wanted to. Like you could make the first, you could put commas where you wanted things or whatever, and then it's a comma separated file. And then it would work in Excel. Blah, blah, blah. So you can take these semi-structured files and do all sorts of stuff with them. You just have to do your thinking and your Bash in the middle.
Yeah. There you go. Handy.
There you go.
The other ones I wanted to save.
This was going to happen.
Yeah, a little extra learning session. Thank you for that.
A little bit of this protest.
Oh, cool. Yeah. I wonder if I'll come.
Good to see you. So this is a bit
good to see you. What was that?
This is a bit of a regular Tuesday night thing.
I think I will want to do it. Yeah, I'm not sure what the exact time which might change, but I think I want to do this. Yeah, once a week for each of my 3 subjects. So each week was for computer systems, and then there'll be one for software modeling and design, which is like the 3rd year programming subject, and then there's some other to be determined 1st year science subject. But yeah, if you want to, do you know much about operating systems and networking?
No.
Well, if you would like to learn some.
Totally.
Yeah.
And I kind of wish I was learning about Git too, but you'll have to.
Oh, you don't know Git?
No.
Oh, damn it. We should have done that because then I could have actually told you something. But I guess I learned stuff from you about command lines, but yeah. Well, maybe Maybe you could still do that a different time. Git. I could teach you Git a different time.
Yes, that would be great.
Okay. What about on I'm
not sure, but
what about on Thursday?
you send me a message.
Okay, I'll send you a message. Cool.
Thursday at 4:52 precisely.
Message David, read Git and regular times. And also, so if you're interested in learning the operating systems and in stuff in this subject, I can make sure that the time I do this is a time that you are often available. Yeah. Okay, cool.
All right, well, that was fun.
Yeah. Thanks for turning up.
Good to see you.
Yeah. Good to see you.
Have a good
protest and yeah. All righty. See ya. Bye.
Bye.
Okay, there we go. We've had our special guest, David. Do I do Git now, or do I just wait for David? I guess I'll quickly do it now, and then I might do it again with David. So, is my battery going kind of low? Okay. Git. You can explain. Okay, what is the point of Git? Git is so when you like have more versions, you're working on something like a program, but it could just be like even some text thing. And you write in this document and you have different versions, right? And you end up like saving these different versions. This is actually more a thing of the past because Google Docs handles this for you, but you like have like essay and then you have like essay version 3, essay 4th draft. You have like essay 4th draft with different alternative conclusion paragraph, and you have like this whole mess of different things. And then sometimes you like don't save a different one and you've like changed something and you're like, oh no, I want to go back to what I had, but you don't have that anymore because you've like, you've saved over it, it's gone now, etc. So these are lots of problems. And these types of things are solved, say with Google Docs, which most people use now. It is handy because it automatically saves all the past versions for you in there. So that's like a version of, I guess, what we would call version control. So Google Docs does it for you in that way. Another problem you might have is if you're wanting to like work with a bunch of other people in some file in the old days, again, pre-Google Docs and things like that. It's like you're sending it back and forth between you, and maybe someone wants to like work on the second chapter and you're working the first chapter, but it's like all in the same document, and then you've got to like paste something from theirs into yours, but then you wait, was mine the more recent, or was that the more recent? It all gets messy and confusing. Google Docs is one thing that handles this quite well for just like editing documents and stuff and collaborating and sharing things. But one other way that you can use, I guess like more generally just with different files that don't have to be specifically in Google Docs is Git, a software called Git. And I guess it's maybe the way I picture then is just like, it's like with Google Docs, but you can use it for other things, but it's also, it's like different and can do like more different things. But yeah, the general thing is that we want to manage having all these different versions. That's like your own versions over time or different people's versions. Not necessarily that you like want to have 100 different active versions of this thing, but just you want to be able to keep track and kind of have a record and coordinate between all these modifications and versions. So I think the easiest way, that's like basically what our goal is with Git, or what the goal of Git is to help us with. But then I think it's easiest to just demonstrate. So let's do this. Share screen. Okay. So let's make it some Git test folder thing. What's happening? Okay. Let's go make directory Git test. And then let's go into Git test. One second, I'm just going to save something to somewhere. Ooh. What's this happening? Okay. What are we doing? Great. So we're in git test and it's empty. Cool. So we want to use Git. We're going to make some files in here and we're going to use Git to manage the versions. A cool thing here is it doesn't just work with a single file as well. So we might have a folder where we've got a bunch of code in different files and we've got a CSS file for the style and it's various different things. And we want to do this version control of tracking the versions across all these files. So first we just got to tell Git that we want it to handle this folder for us and track the version. So the way we do that is with git init. It's initialized and now superficially nothing's changed. It's still just empty. But if we show hidden files, we will see that there is a .git file. And that just is where Git stores all the stuff that it's info for doing things. We don't need to go inside that or worry about it. .git, no. That's why it's hidden with a dot. What do we want to do now? Well, first we can do git status. Yes, it says on branch main, no commits yet, nothing to commit. Yeah, I guess what we want to do, sorry, let me just look up my plan for what to go through here. Okay, cool. So we want to tell Git, I want to tell Git what my name and email is, not for logging in or anything, just as an identifier. That will be used, like, say, if you're working on something with different people, my changes will show that they're done by what my name is. So let's do this. Git config. I guess I should go onto the virtual machine Unimob virtual machine thing for this. Let's see. 2023. Whoops. Did I get it wrong? What is it called? What's the right code? What is 30,023? What's wrong? Oh, I'm in the wrong directory. Sorry, excuse me, I'm bumbling around here. What has happened? Okay, cool. Okay. Okay, actually, we'll just do it here. This has been confusing. Sorry. Okay, so we're going to go use a command, which is, what is the command to tell it my name? Is configure global username. Cool. So you want to go git configure and we're going to tell it that's a global configuration, I guess. And I'm the user and my name is going to be Jalen. We'll just do my name. I guess we can do my full name. Will this work? Git configure is not a git command. Ah, it's just config. Git config global user.name my name. And the reason we're doing these double quotes is because we've got spaces in here. So as we were saying before, spaces in the command line. It would just treat those things as totally separate commands, Jalen allow homes, but we want to say no, that is just one phrase. And we can also do git config global user.name email, which is my email address. Oop. Cool. Great. So now we want to, how do we actually use Git to manage versions and things? So let's make a file, touch, let's call it home.html. I actually don't know anything about HTML, so I'm sure I'll just be doing this wrong. Oh, let's do it with a C file then, because that's what we're actually using for this class. So simple.c, and then we can put something in there using nano. How does nano work actually? Nano. I know you can write stuff in. Oh, wait, we can use the thing that David told me before, right? Which is that we go echo just do some empty function. Will this work? Put that into simple.c. Let's check. Cat simple.c. Cool. I can't even remember if that's correct C syntax now. I haven't used C in so long. Oh no. Let's see what they recommended in the instruction document for this practical class. Yeah, void main. Oh, I forgot to do the brackets for the function. So let's go echo void main, which goes to simple.c. Oh, what's happened here? Maybe this is a problem with using echo. Let's try this alternate version with nano of entering text. So nano simple.c, and then we enter the text. Oh, cool. This is fancy. Oh, looks like an actual text editor thing. We control X and save. Control X. Done. Let's check that that worked. Cat simple.c, and it has. Wait, has it? Yes. Okay. So now we want to yeah, sure what we'll do with Git. So if we do Git status now, just kind of tell us what's going on in this file, you can see we have these two things in red saying they're untracked. So we can see the files exist, but it's not currently tracking them within its version management. But we do want it to do those. So what we're going to do is we're going to first sort of add changes to Git's official record of what's actually kind of locked in now. Not as in it can't be changed, but as in it's, I guess, committed. This will make more sense as we go. We use commit, but before we commit things, we have to add them to like a staging area. So I'll show you what I mean here. So if we add home.html and simple.c. Actually, we'll just do simple.c because that's what we're working with, is the C file. And yeah, I think don't worry about this warning message. And now if we do get status, that's in green. So that's staged. That basically just means when we commit, we do want to commit. So it's kind of like we're piling everyone into the car, and then the car is going to drive off to the destination, which is committing. So we've put this simple.c in the car, and now we can, or maybe it's more like putting it in a rocket that we're shooting off to the moon, and the moon has all our committed changes. So we've put the C in the staging area in the rocket, and now I can commit. So to do that, do I have to do this a special way the first time? Hang on. No. So you do git commit, and then we want to have a message saying what this is. So we'd call it like create simple.c, I guess. And authorize entity unknown. Didn't I already do this? I did that just up here. Huh, okay, let's try it again. And we'll try committing again. Great, and now if we do status. Oh. Yeah. We say there's one untracked file, but that commit has gone in, which we can see by git log. Yeah, shows us we did this one commit, which is creating simple.c. So that is like, so the message is to say like what we changed in that thing, so that we can look back through and see the changes. For example, if we want to go back to an earlier version or something like that. So that is committing. So if we're editing a file, but we haven't committed it yet, you can kind of think of it like it's in our workspace, in our sandbox, and we're changing it. We haven't kind of added that to the official record. Yeah. And when you add it to the official record, Git keeps it and kind of keeps a copy of it. And then you'll always be able to go back to that if you want. Cool. So we've done committing. Now, because this is a C file, C is a certain programming language. We won't get into C now, though we might have to in some later sessions. But yes, when you have C programs, you have to compile them. And maybe for this next bit, I'll actually just do it assuming that people know what like compiling means or programming language means and stuff. But if you don't, feel free to just skip the next like 4 minutes, I guess. Cool. So we need to compile this with a make file. The make file for C is a file which you can use to like compile a bunch of things for you. So if you have like, if you're working with code that's like modular across a bunch of different files, the make file will like handle like, compiling them all and doing it in the right order and including the right headers, etc. But I've forgotten how to actually use the C. So let me go look at an example from when I did this a couple of semesters ago. And then I can make a make file for this. Making a file. Do I even have a make file here? Why is there no make? Make file, beautiful. So, oh, I should be doing this in the command line. Oh well. Mhm. Okay, I'm just gonna like copy that into this. So let's say, mhm. Cool. This is saying what we want for the compiler. We want GCC. Some flags thing. I don't actually remember what this was, but I guess I put it there for a reason. So let's do it again. And then we want to make a file called simple, a compiled executable file, which is going to use simple.c only. And we're going to go see all warnings simple.c. This G flag, I don't know what that is either. Hopefully this will now work as a make file. Which we can find out by how. Oh, I just execute make. Let's see. Did it work? Oh. Why is it not found? Do I need to go GCC make? Oh, I have to install GCC. How do I do that again? No, why so complicated? Maybe we have to do this in the other, yeah, PowerShell thing, even though the colors are terrible. Sorry. Because I will SSH in to the virtual machine. Don't worry if you don't know what that means. So, what have we got here? Ooh. Git test. Let's repeat all that stuff. Gonna make this new file. Simple.c. Void main. Just redoing all the stuff that we did before. And this new destination. Ooh. Cool. Remake that make file. We had C equals GCC. C flags equals I, those things that I did not understand. And simple using simple.c. CWO. Don't worry about what these things mean. I myself have also forgotten what most of them mean. Might get into it in a later session. So let's see if that worked. Great. So now let's run make. Just trying to install the compiler. Cool. Why isn't this make command working? Let's find out. Make. Maybe we can install. Aha, maybe it will not work. No make file found, but I have a file called make, don't I? What do I have to call it? Do I have to call it make file? I guess we do. Word unexpected. Okay. Why is this not compiling? Look at an example for a simple make file. Let's try even just taking out some of those flags and see what happens. Still strange. Word unexpected. Okay. I might come back to these make details later and just stay focused on Git. GCC hello make. Okay, I'm going to copy the format from this other file. Oh no, I can ask about this in the shoot. Yes, probably not worth spending too much time on it now. I can explain it to you though the rest of Git specific stuff. So with compile, what's it doing? Oh, yes, great. So some things we might want Git to ignore, say a compiled file, but I don't know if I have something like, I guess we can just make something to ignore. But for example, it might be like, if you have the actual compiled program, you don't want to be saving that as well, because like you just let people compile the program themselves. You don't want to have this binary on there. You just want the stuff that you're compiling it from. So let's pretend this is, let's just call it fake compiled. And then we're going to tell Git to ignore this. So we go Git ignore fake compiled, and now Git won't use this. Oh, is it a single word? How do you do Git ignore? Oh, you have to create a file. Oops. Git ignore file, which will list all the things. I have fake compiled. And now let's see if it's ignoring that. Yes, and we see that fake compile is not coming up here. Now, there's only one more thing. Yeah, we should do a commit. Let's see. So we can go git add all. Dot is for all. And then git commit add make file and git ignore. Oh, I have to do the M flag for messages. Do I know what this create mode thing is? Great. So the other thing is having a remote a remote repository, so you can have it stored on the internet that you then you change things, and that those changes get sent to the like centralized version, and other people can also do that. So it's a way to work together. So for that, we want to make a repository. Say I could do that on GitHub. We'll just do this imaginarily for now so that it's quicker. Let's say I've got some URL. It's like URL dot dot dot. This isn't going to work here, but I would go git remote. Hang on. Yeah, so I would add the URL and I'll call it origin for easy reference in future. Add origin URL dot 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 dot. Give us an error, I assume. Oh, okay, no, don't know what's happening. Don't know why that's not an error. And then to push to that, which means to send your updates to that centrally stored version. We just do this. So it knows what origin is. And hopefully this will give us an error. Yeah, good. So main is the branch. So you can have multiple different branches. So if I do this, so say for example, if you have a main version of your project and you want to say, oh, what if I did this other weird version where everything was just kind of crazier and all the colors are purple? You can create another branch and do that version. So we would do it by going git checkout B. I assume for brands, I'm actually not sure. And then we want to call it crazy. And now in this view branch crazy. So if we go git branch, it will show us that we have a main branch and then we have a crazy branch that we're currently on. And if we make modifications here, they won't be made on the main branch. If you want to switch back to the main branch, we just go git checkout main. We're back on main. Now say we want to merge them together. It gets complicated. So say like if we made some changes in crazy and we actually want to then bring them back into main, like so we change the colors, but main has also updated. People have been adding new functions, and now we want to like pull those color changes back into this current version of main with the new functions. If you've changed the same things, like the same lines in both branches, it becomes more complicated to merge, but in this simple case, so let's actually change something in crazy so that this example works. Check out, how many A's did I put there? 4 A's for crazy. And then we can say, that is simple.c. And let's say that we add something in here. Printf. Hi. Do I still remember my C? Is this even correct syntax? And now if we want to merge that onto main, we've got to first switch branches. Switch back to main. Because the branch that we want to merge things into is the one we want to be in. So we're in main because we want to kind of pull some things into main. And then we can grab our changes by going git merge crazy. Already up to date. That should not be the case. Because I didn't commit anything, so there's no new changes. So I have to go back to crazy and actually commit those changes. Made it say hi. I forgot the M flag again. Messages. Make it say hi. Great. Now if we go back to main yes, the main branch. Now we can merge and we'll actually do something. There we go. Simple.c, 1 file change, 3 insertions. Cool. So that's merging. And one other thing we might sometimes want to do is if we're working on a project that already exists, say some other people work in a project and we join in, we want to then take that repository from where it's stored essentially and copy it on to our computer so that we can work on it and send commits and stuff. And we do that just by saying we want to go where we want the directory to go. So in this case, we wouldn't want it inside our current directory. So we go just to code and we'd say git clone, and then we'd put the URL where the project was, etc. That would copy it, and then we're done. Great, so that's a kind of a rushed, weird, quick intro to Git. Thank you. If you're actually still watching, that is amazing. And definitely let me know. Shoot me a message. Bye.